In this video, I'd like to plot a sinusoidal function. I'll do a cosine, but right now I've opened up to the Wikipedia page for sine. I'd like to plot that function, sort of plot two functions with different parameters. So we see here in the formula, there is an amplitude that determines how big the oscillations are. The F here determines how frequently the function repeats itself in time. T is the time, so that is the variable in this case. And this phi is the phase. It sort of determines in what part of the cycle that we start in. So again, I'm going to switch over to cosine just because I have this assignment and it's plot in R, either two cosines with different amplitudes or different frequencies or different phases and beats, but I'll probably just do all of them in this example. Okay, so here we go. I'm going to start a new R script and I want to define my parameters. So an amplitude, a frequency, I'm going to switch to the variable being x because I'm going to use curve function in R, and R likes for the variable to be x. I don't have to work as hard. And then the phase, I'm not going to use a phi symbol because that's a little too hard for me to get. So let's just say the amplitude. It's just plotting cosines. Let me save it, do a save as. I'll save it in 152 cosine plot .r for an R script. Okay, I have my amplitude and I'll set that to, I don't know, 1.5. I'm going to have two of them, so I'll do like A1, F1. My frequency will be 2.2. And I'll call it P1 for my phase. And I'll make that 1.3. So I just have some parameters. Let's go with plotting one cosine with these parameters to start off with. And so I'm going to use R's curve. I'm going to give it the function that I'm going to plot, and that is A1 times the cosine. So we must make the multiplications explicit. And then cosine is a function, so it will have its own set of parentheses. And then in those parentheses should be 2 and pi and the frequency. And I'm going to switch this to an x plus the phase. So 2 and all the multiplications have to be made explicit. I believe it's just pi, little p, little I for pi. I'm switching the variable, or sorry, the frequency was F1. And then I'm switching the variable to x. And then I'm going to add the phase, P1. So make sure this is Pi, this is P1. So there is my function. I'm going to say where I want to plot it from. I'm going to say start at 0. Where I want to go to, I'll go to, I don't know, 5. And maybe I'll write a color and I'll make this one blue. So I'm setting my parameter values. I'm using curve to plot my function. I have all of my parameters set, but my variable is the thing that's not set, but that variable is going to go from 0 to 5 and make the plot blue. So there is my cosine with the frequency and the extent to which I'm going up to 5. It's a little bit, could be a little bit nicer. I could reduce the amount of space I'm going over, or I could reduce the frequency to have it show a little bit smoother. So let's do that. Let's go to 3 just to have it look a little smoother. Okay. Now I'm going to copy all of that, and I want to add a second function to it. So I'm going to make these all 2s. I could use the same again, that would work, but I'm going to set myself up for something later. So this is going to be all, I'll change all the parameters to 2s and change the color to orange for this one. And I want to change something, otherwise these 2 curves are going to fall right on top of one another if they're the same curve. So the first one I'm going to change is this amplitude. So I'm going to have a smaller amplitude. The first curve I make sort of sets the y limit. So I want the one with a bigger amplitude first. And then I'm going to add one more parameter here, and that is that add is equal to true. So this is going to not make a new graph, a new plot, but add it to what I already have. And I wanted the one with the smaller amplitude added second, because the first one is what established this range. That was established automatically for me. So now I don't have to run. I've run up to 8. Now let me run the second half. And there is this orange function with not quite as big of an amplitude. So that is, I could add a main, 2 cosines as just a overall title. I can accept this, the x-axis is just really the variable x, so, and it's a mathematical function, so x is fairly reasonable there, though if I wanted to make it t, I could. And then it's just giving me the formula that it's plotting. I can change this with a y lab. I can show the 2 equations or what have you if I wanted to do something fancy with y lab, or I can use a y lab and sort of just take it out. Okay, but that is a comparison of 2 amplitudes. If I wanted to do 2 frequencies, then I would just make 2 different frequencies. Let me say, give them the same amplitude, both 1.5, but change one of the frequencies to, I don't know, 1.7. So the second one, the orange one, will have a smaller frequency, will not go up and down as often. So here's the blue one going up and down more rapidly, and the orange one repeating itself on a slower basis. So that is the version where I'm having different frequencies. The third version that was possible was to have different phases. So now I'm going to have 1.5 and 2.2 and just have a different phase. So let's make this phase 0.6, just to have some different phase. And then these curves are doing the same, but they just start at a different place. So the orange one, cosine, on its own starts, the cosine function itself starts at 1. If there was no, if the overall argument of the cosine was 0, we're not starting at 1, but 1.5 because of our amplitude. And then neither of these functions is starting at that maximum, at that highest point, which cosine does because of these phases. But the The orange one is starting a little higher because its phase is a bit smaller. And these phases are sort of, they go between sort of 0 and 2 pi. So if the phase were too big, it would start to sort of go back to the beginning. All right. And so that was the 3 options where I'm plotting 2 functions, but I had one other option, and that was to add 2. So I'm going to do a little rearranging here. And what I'm going to do is plot, do the curve. Oops. Of the sum of, so here's one cosine plus another cosine, and 2 cosines I'll say added. And this is going to, now what I want to do is have, the phases don't matter. But I'm going to have slightly different frequencies. This is the phenomenon known as beat. So if I add 2 cosines with the same amplitude, A1 and A2 are both 1.5, but slightly different frequencies, then there'll be a time when they're in sync, and then times when they're out of sync and canceling one another. Let's see what this looks like. I don't have enough of this plotted to sort of give an idea of the beats phenomena. So let me take this up this time to 30. I'm not so interested in it being smooth as showing you what a beat does. And here is the idea of a beat, that there are times when the 2 cosines are doing more or less the same thing and you get a very big result, and times when the cosines are sort of doing opposite things and canceling one another. And that's what happens when the frequencies are close but not the same. So they get in phase and out of phase and back in phase and back out of phase. So that is what I wanted to show in this R example. Plotting, we can use the built-in curve. The parameters we have to set, the variable should be X. We want to specify where we want to start from, where we want to go to in that variable X. And then we can specify colors. We can give it the title, the main title. We can label X lab and Y lab. I didn't do any of that, but we could. And if I'm plotting 2 curves, then I should, on the second one, add a sort of an argument of add equals true to get the 2 curves on one plot. So that's what I wanted to show you. Let me save that. Thank you for your attention.